This video demonstrates the atmospheric lighting features of Tidewater Planetarium. Atmospheric lighting is what happens when the sun's light diffuses in the Earth's thick atmosphere and obscures our view of the stars in the sky. Some of the atmospheric lighting features of the program are very intuitive. They show just what you would expect, and some require a little more explanation. The intuitive ones are cool, and that's what we'll start with. But the less intuitive ones, which we'll get to next, once you understand those, they show you some very interesting things about the sun's relationship to what we can see in the sky. So I've paused the simulation here just as the sun is going to start to rise. So we have a dark view of the night sky showing all the stars and the moon. And this bright object here I happen to know is Jupiter. So the planets as well. And then we're going to restart the simulation and we'll very rapidly see the sky start to get a hazy blue. There's Mercury, just came up above the horizon into a dark sky, which is a pretty rare event. And there's the sky brightening up, the stars disappearing, and right now what's left are only the very brightest objects. By now Mercury would have really disappeared, and there's the sun above the horizon making its appearance and obscuring practically everything else. So if we pause the simulation now, I'm going to demonstrate to you the ability you have to change the latitude and longitude of the viewing position. You can just hold down a mouse key like the left mouse button and drag the screen until you get to the view that you're looking for. The right mouse button will do the same thing, but will give you a fine tuning of your position. Then if I restart the simulation, we'll see that the sky again does exactly what you would expect. It starts to darken up, and then the stars pop out where you can see them. So that's cool. It's just what you're used to seeing in the night sky. But if I pause the simulation again and temporarily turn off the atmospheric lighting simulation and switch to the full sky view, I can show you a less intuitive aspect of the atmospheric lighting feature. If I turn on atmospheric lighting now, you're not going to see what you'd expect. Instead, this is what you see. And this requires some explanation. The way to think about this is the program is showing you in the full sky view. At every given point in the sky, it's showing you the darkest the sky will be when viewed from this latitude and longitude at this date. So this part of the sky will never be visible with any darkening. The sun will always be above the horizon when this part of the sky is visible to you. That means that any constellation in there, like Indus, will be completely obscured any time that it's above the horizon on this date. Other objects like Mercury we can see just outside the range of atmospheric lighting. And for an object like Mercury that's always very close to the sun, that's a pretty rare occurrence. In fact, I specifically chose this date so that we would be able to show that Mercury is sitting here outside the range of atmospheric lighting. And we're going to switch to another view, the solar system view, to show why. So here's Mercury, here's the Earth in its orbit, here's the Sun, and if we tip them, we can see that the Earth, Mercury, and the Sun basically make a 90-degree angle. So Earth can, on this date, see Mercury further from the Sun than on almost any other date in the total cycle. So once in Mercury's orbit, and we could probably do a little bit better if we went years ahead to get that 90-degree angle when Mercury was way out at the outer edge of its elliptical orbit. But this is a really great time for viewing Mercury, and it almost never happens. And this view of atmospheric lighting shows us that we have an opportunity like that. Even on this day, we have to get up at just the right time to see Mercury rise and see it above the horizon before the sun gets high enough to obscure our view of it. But this display shows us that we have that chance today. Now I'm going to show you one last thing about, well, I guess a couple of things. Here we see this flat spot at the bottom of the display. What that's reflecting is the fact that sun or no sun, a viewer at this latitude cannot see below that southern latitude because the Earth would get in the way of seeing that. We show those stars to you anyway in the full sky view, but this illustrates the portion of the sky that is just invisible to you from that northern latitude. Now if we use that same capability of grabbing with the mouse and dragging our latitude and longitude around, we can see what happens to atmospheric lighting as you move north and south along the Earth on this date. We can see that if you move close to the equator, the atmospheric lighting obscures just a particular longitude from your view. And if you move towards the South Pole, at this time of year in the northern winter, you'll get a completely obscured sky because the sun is always above your horizon. Conversely, if you move to the North Pole at this time of year, you'll see that you never have any, you have no part of the sky that's obscured all day long. So, if you experiment with this feature of the program, you see some pretty unusual displays, and once you understand them, you can learn some really interesting things about the effect of the sun on the views that we have of the sky from places on the Earth where you may never get a chance to visit. So that concludes our demonstration of atmospheric lighting in Tidewater Planetarium. Other videos will demonstrate other interesting aspects of the program.